Hello, Coach Travis here, coming at you with another calculus video. Well, technically this isn't a calculus video, this is more of a pre-calculus video. This is a video about identifying exponential functions. So exponential functions are a very important class of functions. So it's important to recognize that an exponential function, there's not just one exponential function. There's many millions and billions and trillions of exponential functions. But so what you want to do is, it's not a single function, but it's a function that has certain characteristics. So an exponential function is a function that has certain characteristics. And so as a calculus student, you want to be able to recognize what those characteristics are. And so the idea is that, okay, algebraically speaking, an exponential function is one that looks like a constant a times a constant b raised to the x power. And there are a couple of requirements, and that is that this b, there are no requirements on a, but I guess a should not be 0. But if a was 0, this function would be equal to 0, and that would be boring. So we would never talk about that. So a is a non-zero constant, and b needs to be a positive constant, and b can't be equal to 1. So what we got here is a challenge to try to pick exponential functions out of the lineup here. So some of these functions are exponential and others are not. And so the pro tip here is the key way to identify an exponential function most of the time is that the variable x appears exclusively in the exponent. Okay, so some of these are kind of tricky questions here, because if I look at these, I see that the only place x appears is in the exponent. So all right, so that's why the pro tip said most of the time. But there you got to read the fine print here. And it says that the number that's getting raised to the x power has to be positive. So looking at these, this guy I can rule out. I guess, sorry, I'll use the highlighter. This guy can get ruled out because that number, that's a negative 1/3. And so a negative number is getting raised to the x power, and that is not allowed. And same thing with this. This is a negative 15, and it's getting raised to the x power, so that is not an exponential function either. But I think the rest of these functions are okay, because you got a non-zero constant out in front, so no problem there. And then you've got a number raised to the x power, and that number is a positive number, and it's not 1. So these are all, if I want the ones that are exponential functions, are these 3 right here. And now I can't help myself. I gotta say, if I were you, being a good student, part of being a good student is always asking questions. So there's no such thing as a bad question. So you should be, if I were you, I'd be asking myself, well, wait, why? I mean, why what? Why do we have these requirements? So that's the interesting thing about mathematics, is that everything in mathematics happens for a reason. So, you might wonder, well, why do we say these are not exponential functions? I mean, well, yeah, they don't satisfy the definition, but why did we make the definition that way? I mean, we're in control of mathematics. We as human beings make mathematics up, so when we get to make the definitions. So mathematicians, when they decided to define exponential functions, they said, well, we want b to be positive and we want b to not be equal to 1. And you should say, well, why? And so mathematicians, they have a reason for doing everything. They don't do anything arbitrarily. So mathematicians have good reasons for these requirements. And as good students, we should understand what those reasons are. So let's just real quickly talk about that. So first, let's think about, well, why do we want, why do we not want b to be equal to 1? So, well, let's think about what would happen if you had an exponential function where the b was 1. So an exponential function where the b, or a function where the b is 1, would be like f of x is equal to, say, 5 multiplied by 1 to the x power. That would be, if the b was equal to 1, then this is what you'd get. And if you think about that, well, 1 to the x power, that's always going to be 1. So that's just going to be equal to 5. And the problem is that's just a boring function. That's not really, that's a linear function, right? If you were going to draw the graph of that, it's just going to be a horizontal line at y is equal to 5. So that's not an exponential function, that's a linear function. So that's why this is a requirement. That's why we don't let the b be equal to 1. So sometimes when mathematicians make definitions, the reason why they have technical conditions in their definition is so that the definition is not boring. It's so that the definition is interesting. And let's see, okay, and then the b has to be greater than 0. That's a little bit trickier. But here's kind of the reason why. Let's look at this function right down here at the bottom. Let's imagine what happens if we put a square, if we put a fraction. If we put a fraction into that function. So suppose I ask, what is k of 1/2? And okay, well, I'm going to get 11 multiplied by negative 15 to the 1/2. Oh, and sorry, before I go any further, let me make it clear what I'm doing here. I'm explaining, so this is a perfectly good function, sort of. This is a function. If someone walks up to you on the street and says, give me a function, and you tell them this, you've answered their question. The issue is this is not an exponential function. So this is a function, but the problem is it's not a very nice function. It's not, exponential functions are nice functions, and this is not a nice function. And you should be saying, well, hey, why not? Why is this not a nice function? And now, so what I'm showing you now is why it's not a nice function. So let's plug in 1/2. If we put 1/2 into this function, we get 11 times negative 15 to the 1/2, which at first glance is no big deal. But if we think about it a little bit more carefully, then we'll remember that fractional exponents mean roots. And so this means the square root of negative 15. And so since we're only, and this is not a real number. So for the purposes of this class, this is out of bounds. So the reason why this is not a nice function, and one of the reasons why we say it's not exponential, and the reason why we don't allow negative bases in our exponential function is because they end up giving you imaginary numbers. If you let b be a negative number, then you're going to have a function whose range includes imaginary numbers. And now that might be something you're interested in, but for the purposes of our class, that's out of bounds, and so we'll say that's not an exponential function. Okay, so now we got another, I've changed problems, so we got a new problem here. It's the same idea, identify exponential functions, and so on and so forth. So all right, so let's go through this. So for one by one. Okay, so this is not an exponential function because the idea was an exponential function is where the variable is in the exponent and kind of everything else is a constant. Whereas, so in this one, the exponent is a constant and the x is in the base. So technically what this is actually known as a power function. And that's not, a power function is not an exponential function. So that, we got to cross that one out. And then, all right, the next one here, the exponent is a variable. That's good. And then the base is a constant. Sorry, yeah, the base is a constant, which is fine, but more importantly, the base is a positive number, and it's not equal to 1. So even though it's a fraction might look a little bit scary, but that's okay. An exponential function can have a fraction as its base. As long as the fraction is a positive number. So this one's legit. That is an exponential function. Next one here. Well, you guys should know what kind of function this is. This is a linear function. If you graph that, you just get a line. And so there's no exponent. So that's no way that's an exponential function. The next, let's see. Oh, and the next two look pretty good. Because, okay, the exponent is a variable and the base is a positive constant. So sure, it's a fraction, but there are no rules against fractions. The only rule is that it has to be positive and not equal to 1. So that one's good. And same deal with this one. That one's also good. So we got, in this lineup, there are 3 exponential functions. 1 power function and 1 linear function.